I'm Paul Elliott with Hashrocket TV, and I'm sitting here with Redmond, the author of 7 Databases in 7 Weeks.
That is true.
Now, it's a great book that gives kind of a high-level overview of 7 different databases. Can you tell us a little bit about the book and what it covers and why we should read it?
Sure. Well, I think the title is pretty self-explanatory. Mm-hmm. The idea is that there's 7 databases, and you cover each one over the span of a week, and after 7 weeks, you'll know 7 different databases. But really, the crux of it is not so much the individual technologies as much as the idea that it gives you sort of a handle on all of the different types of data stores that are out there. There's relational data stores, document data stores, key value, columnar, and graph data stores. And we sort of give you an understanding of those different types through implementations that reflect those types.
Okay, great. Well, I know it's a fantastic book, and it's great that you're still talking about relational databases, because everybody's so caught up in the whole like Redis and Mongo and all these new kinds of data stores who forget that we still have these amazing relational databases too.
Yeah, absolutely. And that's where my background is. When I was in college, I would probably spend most of my time, most of my research dealing with relational databases, as did everyone, mm-hmm. Up to a couple years ago. And so I didn't want to just jump straight into NoSQL without at least discussing not only talking about relational databases. In this case, I use Postgres as the example, but also the fact that there are things that people don't realize you can actually do with a relational database. Mm-hmm. And before you make the decision to jump into a database like Mongo or Couch or something like that, understand that many of these options actually exist in the relational world. So yeah, don't ditch 40 years of experience. One of the new shiny thing.
Really exciting things that's come to my attention recently that I didn't know about Postgres had was the H store.
Yeah.
And I know it's available on Heroku if you're using Heroku's databases.
Yeah.
You can take advantage of that.
Fairly recently. And it's actually not something I cover much in the book, unfortunately, because I didn't realize how popular the topic would be. But I do go over things like people don't realize how flexible its full text searching is, or mm-hmm. The multi-dimensional indexing mm-hmm. that you can do. I mean,
there's some really cool gems out there that extend active record to give that mm-hmm. support for those things too.
Right, like PG search is a great one.
Now, speaking of the H store, what could you use that for? Like, how does it compare to a document data store or some other similar thing?
Yeah, that's actually as H store has gotten more press. It's a common question. For one, a document data store has no limit on nesting. So whereas H store, you can put in hash for people that don't know what an H store is, I should probably back up. H store is a way to put in a hash value as the column of a relational database table. Mm-hmm. And that's fine, except that's all you get. You just get that one hash. A document data store is nested, and you can have hashes and arrays, and the values of those can be further nested hashes and arrays. So you can just nest n values deep.
Okay, so it's much more limited, obviously.
It is. It's considerably more limited. It's also.
How about searching against that? Is it easy to search against that with Postgres?
In Postgres? Yeah, yeah. That's part of the H store spec. The idea being that you can query against those values, because otherwise you're just storing a blob. And there actually is a JSON data type that you can do as well, and I think it's been supported for a while now. But you can't query on it. You can't query on individual values that have been stored inside of that JSON object in the way that you can with HStore, which is why you should generally use HStore rather than JSON.
And that's an important thing to know about too, because a lot of people probably are using MongoDB or another database like that because they want to get some basic hash stuff in their database, and when they could have just used an HStore and then
that's true. If you know that you're not going to nest more than one level deep and you're really comfortable with relational databases, definitely give Postgres a second look. And there's other data types as well, like arrays, for example, other weird data types like cubes and things like that.
Yeah, there's been a number of blog posts on that topic pretty recently. When you're getting started on a new project, what kind of criteria do you use to evaluate what sort of data store you want to start with?
Well, generally, I'll start with a few high-level questions. A lot of it is, I know that premature optimization is the root of all evil, so you shouldn't necessarily jump straight into, how am I going to optimize this? But you're going to have a general idea of where you want to be. And if, for example, you are building a social network, you know that where you're attempting to go is, mass market, and you're going to want, millions of people hitting this all at once. It's going to be a different kind of criteria than, for example, if you're writing a bank application, or if you're going to you're writing some sort of shopping cart application like Amazon. All of these different databases arose out of a reaction to real world problems. And it's not like somebody was just sitting around and said, you know what, relational databases are fine, but let's write Mongo instead. Mongo, just for example, was created because there were limitations to the current offerings of relational databases at the time.
Like how they're not web scale.
Web scale, yes, exactly, precisely. I mean, it was created by the guy who it was AdSense, I believe, was his initial project. He was CTO of AdSense, and forgive me, I actually forgot his name. Was Elliott? Is that correct? Anyway,
I don't know.
So he said, okay, well, I'm going to write this database that I wanted while I was doing this, because trying to shoehorn at the time, like MySQL, was a problem. So overview, I would say when you're talking about something like, if you're just looking for sort of simple, scalable key value lookups, look at something like Redis. If you need very high availability, like as far as, if it costs you money to be down for a fraction of a second, look at something like Riak. If you sort of need all the cool like relational tools, and if you have a very structured data model, but you're not really sure how you're going to query it later, look at something like Postgres. If the opposite, if you're not really sure what you want yet you are, and that's your big problem, then look at a document data store like Couch or Mongo or something like that, because they're very flexible. You don't have to do these schema migrations or anything like that. So you can sort of pivot your data model at will.
Sure, and these are some of the things that are covered in your book.
Right, absolutely.
So if you're thinking about starting a new project and that is a question for you, definitely you're going to want to check out the book.
Yes.
Cool. So one of the questions that comes up is planning for high availability and scalability concerns on your data layer later on in the project.
Sure.
Is that something you should worry about that much in the beginning? Or is that something you should just deal with as you get to it? Premature optimization is something that always comes up when we're talking about this. Like how much of it is a valid concern early on?
Right. Well, in some cases it's not so much of a valid concern, and I think probably a great example of that is look at Twitter. Twitter is massively scalable, and they actually still run a lot of their architecture on MySQL. And so part of it is a premature optimization issue. Now that said, I guarantee if Twitter had it to do all over again, they probably wouldn't have gone that direction. But of course, at the time, there weren't a lot of options out there. So I wouldn't consider it a premature optimization to at least be somewhat forward-thinking in what direction you want to be in. If you're writing an application for say, a configuration application for enterprise, and you know that at no point in time are more than 50 people going to be using it,
Right.
you don't need to worry about, web scale Mongo or anything like that. Now, you can use Mongo for an entirely different reason. If you have a very flexible data model and you think a schema would be too rigid, it might be a fantastic choice. And this is exactly why in the book we place such a premium on understanding those databases and understanding these topics and understanding these we call database genres, because it will give you a deeper understanding so that you can make these decisions in advance.
This reminds me of the early days of Rails when everyone was talking about Rails doesn't scale,
Right.
and DHH is like, that's a great problem to have if it can't handle the load that your site is getting,
Yes.
And deal with it when that happens.
Yeah, and there's some truth to that, but different databases or different database genres, different database styles exist for vastly different purposes. For example, React was created solely to handle high availability, high uptime. And because it was patterned after Amazon's implementation called Dynamo. Dynamo paper was designed because the Dynamo database was designed because they realized that if lag was a fraction of a second, it would cost them real money, and they had it down to a dollar figure in the paper, saying, if it's 0.5 seconds slower, it's going to cost us 3% of our revenue. So uptime is very, very important to them. So that's what React is focused on. So again, if you need that sort of super high availability, go with React. If you don't need it, it might be more than you need, and so I would just look at something else.
Now, with all of the major database offerings that are out there, they're all pretty performant, and they can all handle a whole lot of load. So in choosing one based on the kind of data that you're going to put in there seems to be way more important.
Yeah, it absolutely does. And not only that is, you also need to choose when, I don't know how else to phrase this, when you want to feel the pain. A relational database, you feel the pain up front. You have to do, you design your schema, you say, this is what my data model is going to be like. You have to handle those migrations while you're doing development. Development time, I don't want to say it's slowed down, but you definitely have to deal with it as your data model evolves. Whereas something like Mongo, you don't really have to do that. You just say, okay, well, I want to start adding fields, so you just start adding fields. And it turns out that I need to nest this other data inside of you, just to add data inside of it. It's not a big deal. That said, if you have a very highly normalized relational model, you can query it any way you want. Whereas Mongo, it might be really easy to shove data in there. It might be a little more complicated to pull data out. And so you're going to then sort of feel that pain on the back end of, okay, now how I'm going to actually query this. That's not to say that there's anything at all wrong with Mongo, because really, in reality, they're kind of two different use cases that most people don't. Nobody hits a wall. I mean, you'll have to just design ways around these limitations on both ends.
So one of the things that I keep hearing people talk about is decoupling your domain model from your data store. And one of the big reasons for doing this has been cited over the years is so that you could potentially switch databases down the road if you want. And this reminds me back at the old days of n-tiered architectures when we had all these different layers of EJBs separating things so you could swap out components. How valid is that anymore?
In some ways, it's still valid, but I would say in many ways it's not. A lot of this fear is almost a sort of an archaic holdover from back in the day, where you didn't have open source databases and you really had to be concerned about vendor lock. It was a huge issue, because if your vendors started changing their licensing or adding unneeded complexity and requiring, okay, well, now you're going to have to start hiring consultants, and they're going to be our consultants. They're going to cost you $1,000 an hour, and that might sound absurd, but that actually wasn't far from the case
Oh, yeah.
at the time. These were very valid concerns. So this idea propagated in the development community is we're going to decouple ourselves from the database as much as possible by having these 3-tiered architectures or n-tiered architectures, because if Oracle starts overcharging, we could easily switch over to Sybase or over to DB2 or something like that. The reality is, if you're developing on top of Mongo and you decide, oh, I'm going to switch to Couch, you're probably going to have to make some changes anyway. Yeah. Or if I want to switch to an entirely different type of data store, like back to a relational database, if you decide, okay, the document data store is not what I need, you're going to have to do that migration. You're going to have to do that translation. You're going to have to do that load, that ETL. But it's not as common as you might think to swap out databases, because it's not as much of a concern, because all these databases that I cover are open source.
Right. So as long as Oracle doesn't swoop in and buy the open source project, then you're pretty safe.
Yeah, but even in that case, it's not that much of a concern, because
right.
I mean, MySQL is still it's still a choice that you can do, and it's still open source, and you can fork it. And there actually are forks out there, like Drizzle, I believe. I don't know if it's literally a fork of MySQL, but it's at least a spiritual fork.
Cool. So let's say hypothetically your publisher came back to you and said, Eric, this book isn't long enough. We need some more content in there. Can we make it 8 databases in 8 weeks? What database would you add?
Well, the first thing I would do is punch someone. This is a very long book as it is. I think it tops about 350 pages. But that said, if I had to add an 8th database, there was one database that we had originally had on the docket, and we actually pulled it out and replaced it with Couch, and it was called OrientDB. It's not a well-known database, but I find it intriguing because it's sort of a class of database that it's sort of emerging, that I would just call a hybrid database. It can act as a key value store, it can act as a graph data store, it can act as a relational database. It can act as all these sort of different styles as you need it. Now, that said, you do have to choose sort of in advance how you're going to use it, and you set it up that way. And you might say, where's the benefit in that? Why wouldn't I just sort of do a best of breed version, just say, here's my graph data store, and here's my document data store? And the fact is, because the engine still has access to all of that data, you can view it in different ways. So you can have the same common data store and say, okay, well, I'm going to act as a graph data store against this style of data. This maybe, for example, user permission data, which is very well suited to a graph, as opposed to sort of session data, where it would be very well suited to a key value store, but it would be just one database.
Okay. Great. Well, thanks for taking the time to talk to us. 7 databases in 7 weeks. Definitely check it out. It's an excellent read. Thanks.
Thank you.